Have you ever felt backed into a corner? Like you're facing a challenge where any move you make is somehow the wrong one.
Oh, definitely. That feeling is really at the heart of what we're looking at today.
Yeah, it comes from this fascinating article by Kadir Kubeshuk called Duolo. That's dual in English. He talks about this intellectual challenge he faced.
And it all started with what looks like a pretty simple math problem. Deceptively simple, really.
Totally. So imagine someone presents you with this. Okay, $1 plus 4 equals a 5-1. That's fine. Then $2 plus 5, 4, 2. Then $3 plus 6 2 into 1, $1.
Right, you see the pattern starting to, well, diverge from normal math.
Exactly. And the question is, what does $8 plus 11 equal? So for you listening, the mission here is to figure out not just an answer, but two possible answers. See the trap hidden inside and understand how the author handled it.
There's definitely an aha moment waiting here.
So let's think. What's the first pattern that jumps out? Your brain's trying to make sense of $2 plus 5 plus 12, 2.
Well, the first line, $1 plus 455, that's just straight addition. But the second one, maybe there's a new rule. Like maybe you multiply the two numbers, A times the dollars, and then add the first number, A, back again. So A plus B actually means A times B plus A.
Okay, let's test that. For $2 plus 5, 5, that would be $2 times 5, which is 10, plus the first number, 2. So $10 plus 2 equals 12, 2. Hey, works.
And does it work for the next line? $3 plus 6 equals $201.
Let's see, $3 times $6 is 18, plus the first number, 3. $18 plus 3 equals $21. Perfect. It holds up.
So if we stick with that rule for the final question, $8 plus $11.
Right, that would be $8 and $11, which is 88, plus the first number, 8. So $88 plus $88, that gives us 96.
Seems like a solid answer following that logic.
It does. But you mentioned another way, didn't you? This is where it gets interesting.
Yeah, there's a second pattern you could spot. It's a bit different. Instead of a fixed rule for each line, it builds on the previous result.
Builds on the result? Yeah, how so?
Okay, look. $1 plus 4 equals 5, 5. That's our starting point. For the next line, $2 plus 5 fives, you first do the simple sum, which is 7. Then you add the result from the previous line, the 5. So $7 plus 5 equals 12, 2.
I see. You carry the previous total forward.
Exactly. Let's check the next one. $3 plus 66, simple sum is 9. Add the previous result, which was 12. $9 plus 12 plus 21 guaners. It works too.
Wow, okay. So two different logics that both fit the examples given.
Right. So now we apply this second logic to the actual question, $8 plus 11 one other.
Okay, so $8 plus $11, the simple sum is 19. Then we need to add the result from the previous line, which was 21.
Yep. So $19 plus 21 $1.
That equals 40.
So now we have 96 from the first method and 40 from this cumulative method.
And both seem perfectly valid based on the numbers we were given. This isn't just math anymore, is it?
Not at all. This is the trap. That's the brilliance or maybe the sneakiness of the setup. The challenger created a problem with two defensible answers.
Meaning, whichever answer you give, 96 or 40.
They could just say, no, I was thinking of the other pattern. Making your answer technically wrong according to their hidden rule. It's a constructed dilemma.
It really puts you in a bind. The article mentions the author feeling cornered, like there was no way to win. But clearly, they found a way out. How? What did they do?
Well, instead of just blurting out 96 or 40 or arguing for one method, the author did something quite clever. First, they actually complimented the challenger on how ingenious the question was.
Flattery. Okay, interesting start.
Yeah, disarming. Right. Then they explicitly acknowledged both solutions. They basically said, look, using method A, the answer is 96. Using method B, the answer is 40. Both are valid, depending on the underlying assumption.
Okay, laying it all out. But what's the final move?
The crucial step, they turned the question back onto the challenger. They asked something like, so which condition, which logic were you applying in your mind when you posed the question?
Ooh, that is good. That completely flips the script.
Exactly. It forces the challenger to reveal their intended logic, their hidden rule. But since the author had already worked out both possibilities...
They were ready for either answer the challenger gave. They couldn't be caught out. Brilliant.
Yeah. The author essentially diffused the trap by exposing its mechanism. The article even briefly touches on Aristotle's category of time, suggesting philosophically that both answers could be true, just under different contexts, different implicit rule sets. And it mentions logic concepts like the simple constructive dilemma.
Basically saying you don't solve these kinds of traps by just picking a side. You have to go deeper.
Precisely. You have to address the setup itself.
So the real lesson here isn't just about getting the right answer in a math quiz. It's about recognizing when the game itself might be rigged, or at least when the rules aren't clear.
It's about looking at the underlying assumptions, questioning the framework of the problem you're presented with.
And for you listening, trying to get smart insights quickly, this little duel shows how even a simple puzzle can unlock layers of, well, strategic thinking. It's a reminder to look beyond the surface.
Yeah, it makes you think.
Definitely. So here's a final thought to chew on. Think about times in your own work or life where maybe you felt trapped between option A and option B, and both felt wrong, or like losing choices. Could there have been unstated rules or assumptions at play?
What might happen if, instead of just choosing, you started questioning the rules of the game itself? Could that open up entirely new paths forward?
Something to consider.